to your Core Pure 1 Chapter 3 series chapter summary. So this is a really short chapter. It's only 3 formula that you need to remember for this. You go more in depth for this in Core Pure 2. There's only one bit of the spec that we need to go through here. It's this. The formula for sums of integers, squares, and cubes. So the formula that you need to know are of integers, so that is n plus 1 over 2. Sum of squares, just n plus 1, 2n plus 1 over 6. Sum of cubes is n squared, n plus 1 squared over 4. These two are given to you in the formula booklet, but this you need to remember yourself. If you're struggling to remember, you can derive it by just doing, maybe you've heard of the story of how it was first derived. So we've got this list of numbers, right? Let's go 1 to 6. The way you're going to find the sum of it is right or backwards, right? 6, 5, 4, 3, 2, 1. Add them all together. So now you have n lots of n plus 1, right? So you have 6 numbers, n lots of 7. And find the total, thus this, you're going to have to divide that by 2. And there's where our formula comes from. And these formulas are going to allow us to find the sums of this. So we can rewrite this as n r plus 1. This can be r cubed plus 2r squared. And what this is, so our limits are n and r plus 1, right? So we're finding a sum of every value from r plus 1 to n. So we can also rewrite this as n r plus 1, n over n1 cubed, just 2r squared, minus r1 r cubed, 2r squared. Because then we're getting rid of everything from 1 to r. So we only have values, sum of values from r plus 1 to n. So we can just plug in our formula. So that'll be n squared n plus 1 squared over 4 plus 2n plus 1, 2n plus 1 6 minus r plus 1, 4 plus 2 n plus 1, 2 plus 1 over 6. And then with our values, you can plug in our values of n and r and get the answer. Well, that was basically it in terms of what we have from the spec. I told you this was quite a short chapter. Now I'm just going to go through some exam questions. So with part A, so you've got sum of n from 1 to n, r times r plus 1. So you can write as n equals 1, r squared plus r. So you can use our formula. That will be n plus 1, 2n plus 1 plus 6 plus n plus 1 over 2. Now we can factorize a lot of things. First, I think to get everything here as integer, factorize out 1/6. So that would give us n plus 1, 2n plus 1. Then times everything here by 3, plus 3n, n plus 1. We can factorize out n and n plus 1 here as well. So you can have 1/6 n plus 1, 2n plus 1, plus 3. 6n plus 1, 2n plus 4. See, this is even. We can take out 2. So 1/6 times 2, n plus 1, n plus 2. That was 1/3 n plus 1, n plus 2. Let's see what the question asked us. We want n over 3. So we've basically got that. We write that as n over 3, n plus 1, n plus 2. Perfect. Okay, for part B of this question, this isn't about too much about series per se. This is more being perceptive and being able to use what we found up here and apply that here. So you've got just a lot of random logs, right? But the first thing I would notice is these are all powers of 3, right? So this is 3 squared, 3 cubed, 3 power 4. Then this you'll find would be 3 to the power of 12. What I'm also noticing here, that the power is always 1 greater than the value of the term. So first term, this is 3 squared, 2, 2, then 3 cubed, 3 and log 4, 11, 12. So what I'm seeing here, then this is n log 3, n plus 1. Because of our log laws, we know that we can bring this back here, bring down. So it's n plus 1 log 3. And because we're adding this is just a sum of n plus 1 log 3. So we know n is going to be 11 because that's our last term. We're starting for 1. So we can just sub in 11 into our identity here. So this would give us 572 log 3, which would be our final answer. It's actually not too much working for 4 marks, which is very nice. To finalize answer, you can say P is equal to 572, Q is 3. Perfect. Okay, for this question, we'll start off with this. So start with cubes first, n positive odd numbers is this. So the first bit of thinking that we need to do is how can we put this as an expression, n positive odd numbers. Call an odd number, that would be 2n minus 1. You could say it's 2n plus 1. I would avoid that because then when you're starting from 0, you're actually skipping out 1, which would maybe cause some problems later on. So we'll call it 2n minus 1. So we want a sum of cubes. So we'll cube 2n minus 1, which is 4n squared minus 4n plus 1. Okay. That gives us 8n cubed minus 12n squared plus 6n minus 1. So sum of cubes is 8 times n squared n plus 1 all squared over 4 minus 12n plus 1 plus 1, 6 plus 6 2 minus n. Okay, now that we've got this, you could just factorize a lot of things. So you've got 2n squared n plus 1 minus 2n plus 1 2n plus 1. So we can factorize our n here. So we can get our n 2n n squared n plus 1 minus 1. Now here it's a lot of difficult expanding, which you'll clear up later on, but here it gets a bit messy. So start here, 2n n squared is 2n plus 1, 2n cubed is 4n squared plus 2n. It's minus 2n squared plus 3n plus 1 becomes minus 4n squared minus 6n minus 2, 3n plus 3 minus 1. So that'll get n, 2n cubed, it's fine. These bits cancel. 2n minus 6n, 3n, that gives you minus n. And 3 minus 2 minus 1, that cancels as well. So you're left with this. Factorize our n, so n squared, 2n squared minus 1. Perfect. Okay, part B of this question says, solve the cubes of 10 consecutive positive odd numbers is this. So I want to determine the smallest of these 10 consecutive positive odd numbers. Okay, so this question, despite it being worth 1 less mark, this is a lot more painful, a lot more tedious algebra. So it says 10 consecutive numbers, right? So I think we can start by saying it could be n plus 9. Yeah, so that will make the 10 consecutive integers. This is just n plus 9 to 1 minus n minus 1 to 1. So we're only finding the sum from n to n plus 9. So this will give us, if you sub in n plus 9, n plus 9 squared, 2n plus 9 squared minus 1, which is n squared plus 18n plus 81, 2n squared plus 36n plus 161. And then with n minus 1, that will be n minus 1 to n minus 1 squared minus 1, obviously. That will be 2n, n squared minus 2n plus 1, 2n squared minus 4n plus 1. Multiply this out. I actually did this beforehand, so I wouldn't have to sit in here and bore you. But this essentially gives us 2n power 4 plus 72n cubed plus 971n squared plus 5,814n plus 1,741. This one, the other side, gives us 2n power 4 minus 8n cubed plus 11n squared minus 6n plus 1. Minus that gives us 80n cubed plus 960n squared plus 5,820 n 13,040. So that equal to 99,800. So final cubic is 80n cubed plus 960n squared 5,820 n plus minus 86,760. And at this point, you've made it so far. I don't think they really mind you just stuffing this into the calculator. So that gives you n equals to 6. That would be your solution here. So this isn't actually our final answer. The question asked for some positive odd numbers. Obviously 6 isn't odd. So I sub this into 2n minus 1, because that was what we used originally, right? As n. So 2n minus 1, 6. 2 times 6 minus 1, 11. So smallest number is going to be 11. Okay, that's all from me. Bit of a short one today, but I hope you enjoyed.